I started off as an undergraduate student studying developmental biology. How does a salamander become a salamander, a snake become a snake, and a chimpanzee become a chimpanzee? Then I started to realize that my real interest wasn't in what makes a chimpanzee, or a snake. It was in what makes two chimpanzees so very different from each other. So then I started to realize that the people asking those questions were psychologists. And I came to the conclusion that the best methodologies were owned by biologists, but the best questions were those posed by psychologists. So I started to become interested in individual differences. And in particularly, a question that I think is fundamental in medicine is, why do some people get sick and others don't?
For more than 20 years now, Michael Meany has been researching intensively what makes us sick and when in our lives important factors occur influencing our health. Many of his findings are of global relevance and importance. Chronic stress has negative consequences for our health, and stress reactions in animals are linked to parental care at a very early stage of development. This was the basis of Michael Meany's studies with rats, with which everything began.
The studies with the rats, for example, allowed us to get at the basic questions. Every organism on the planet has at least one parent, and the parent signals the offspring in different ways. And that produces variation in the developmental trajectories of the offspring.
Meany and his team did not just want to find out the extent to which maternal care influences the development of offspring, but also how enduring this process is for development later in life.
The essence of what we had found in the rat was that the quality of the early social environment altered the activity of specific genes in a brain region known as the hippocampus. Genes that we know influence the way in which individuals respond to stress. So when we translated that into humans, our first challenge was, of course, to get the human hippocampus.
In 2008, Michael Meany began looking at brain cells from human corpses, hoping to be able to show that the findings from the rat studies could relate to humans.
Hello, I'd like to welcome you to the Douglas Hospital, and particularly to one of our unique features. This is the Douglas Brain Bank. It is the brains contained within these jars that has allowed us to translate our epigenetic studies with the rat into humans.
Epigenetics is the science of molecular mechanisms leading to stronger or lesser gene expression. But Michael Meany did not just carry out epigenetic tests, he also went a step further.
And the challenge then was really to be able to relate them to the developmental history of the individual, and this we managed to do through the forensic phenotyping, the interviews with families and members of the community of individuals known to the victim. So it was this information that allowed us to understand that the differences in the activity of the gene in the hippocampus was associated with the history of child abuse. So this is the way we translated it into humans.
When we hear the word genes, we often think about unchangeable inherited features. However, the activity of certain genes, and this is something Michael Meany's epigenetic studies have shown, largely depends also on one's social environment from an early age.
So you may have inherited a particular genetic sequence, but what's really important isn't simply the sequence, it's how active that gene is within any particular cell. So the sequence, of course, is unalterable. And your mother isn't going to behave in a way that's going to change your sequence, but she can behave in a way that changes the activity of the gene. An epigenetic mark acts as a dimmer switch. So it changes the structure of the gene, and thus turning it on to a greater extent, or dimming its activity.
Scientists already knew before that traumatic experiences strongly influence one's psyche. It was also known that genes play an important role in this process. What is new about Michael Meany's studies, however, is that they made it possible for the first time to understand the biological mechanisms through which certain traumatic experiences in life alter the expression of genes. Does it all come down to nature or to nurture? Michael Meany's studies show that both are closely linked to each other.
I think our biggest achievement was to put those two together. We understand now that what you come with by way of nature is shaped and molded by what you experience by way of nurture.
The Canadian research team also researches epigenetic signals in mother-child studies at different stages of development. The focus here is on the question of reversibility of epigenetic signals, and more precisely, of those biochemical processes that make children especially vulnerable. Translating the results of these studies into concrete interventions has already begun on several levels. They place great importance on sharing experiences with those active on an everyday basis in Montreal's most vulnerable neighborhoods. For example, Dr. Gilles Julien, who collaborates closely with Michael Meany.
We met frequently in different situations, and we always said to each other, we should work together, we should do something, because we found that we're really having the same passion for supporting child development.
Yeah, I think the key from our standpoint is to shape the research to fit the intervention program, the questions of the people who are bringing the interventions to the children, as opposed to coming in with a specific interest of our own. It's really to let the intervention shape the research. That's what makes the research unique.
Michael Meany already has new projects for the future. A newly created data center will create an even broader basis for the findings of his research.
So our work with the Jacobs Foundation is part of a new center that we began at McGill. And so this center, the Ludmer Center for Neuroinformatics and Mental Health, has as its objective the ability to be able to mobilize the biology that we collect on patients and on their brain function, and ask how can we meaningfully use that to improve diagnosis, and most importantly, can we use that data to predict which patients are going to respond to which treatments. So this is the broader goal, and that's the mission yet unaccomplished.